should be simulcasting to YouTube.
Cool.
All right.
Alrighty.
Good stuff. Okay, so let me double check show notes. Make sure those are handy.
Do we still need to do the clap thing?
Yeah, we should, just to make life a little easier for the editing.
I was like that. That's why I asked.
All right. I think we are good to go. So we'll do the sync clap on, so after 1, 2, 3 on 4, okay?
Okay.
1, 2, 3, 4.
Oh, crap. I don't know what happened there. Yeah. I gotta get ready.
You gotta get ready. 1, 2, 3, 4.
All right.
All right.
That one was embarrassing, but we got it. We got it done. We got it
It'll
done.
do. It'll do. All right. Let's get rolling with the intro theme here.
Cool.
Let's do it. It's go time.
Welcome, friends, and those who want to be friends. You want to be friends with me, right, Aaron?
Of course. Why do you think I'm here?
Okay. Awesome. So today we're going to talk about functional programming with generics. So I am your host, Johnny Boursiquot. If you haven't heard from me for a while, that's because I've been heads down trying to ship some stuff that's coming out later this year. And I'm pretty excited about it, but I can't spill the beans on that yet. You're just gonna have to stay tuned, and if you want, you can go to golangjohnny.com.
Nice.
Since I own that, I made sure to snap that up. Last time John Calhoun mentioned it on a show. So joining me today is you know him. He's been on the show before, and you see his name everywhere, and especially as it relates to things like GopherCon and getting us ready for the big show coming up next month, actually.
Coming up.
Please join me and welcome Aaron Schlesinger.
Hi, everybody. Thanks for having me, Johnny. It's wonderful to be here again.
Yes, and it's great to have you. So, we did a show on functional programming a little while back. This was episodes 87, right? This was a while back. This was like May something of, let me double check real quick. 2019, back in 2019. So a lot's happened in the Go world since then, right? Most notably the introduction of generics in 118, right? So it was suggested, actually, there was a listener who basically went back and listened to the old show and basically said, hey, I found an episode on functional programming from back in 2019. However, it was a time before generics appeared in Go. It'd be nice to hear what can be done with functional programming and Go with generics. So this was from Steve Nicholas. So Steve, shout out to you. We indeed got this show put together on your suggestion. So others, you can follow in Steve's footsteps if you want to ask for certain shows, and you can basically suggest them, and we often look through the list and see what's interesting, and you tell us what you want to hear, and we put on shows like this as a result of that. So you and I, along with Matt, were basically we did that episode, and we learned a lot during that time. We learned how to use what we had back then, mainly things like the empty interface and things like even generators, right, and things like that, and even sort of using reflection, right, because those were some of the things that really sort of enabled or facilitated the creation of functional programming sort of style libraries and things like that, or approaches to Go. But those were also some of the gripes, right, with trying to do functional programming in Go, right? Too much use of the empty interface, too much use of sort of reflection, on and on, right? And even the thinking that, well, Go is really for imperative programming, right? The verbose style, right? Not really suitable for functional programming. But I think we made a pretty good case for it, right? And listening back to the show. But now that we have generics, right, I wanted to bring you back so we can talk about what are some of the really some what's easier now to do with Go, like what was hard to do then that is easier to do now.
Yep.
So
Yeah.
so where are you thinking we start first?
Well, I think maybe we can do a little bit of a recap of what FP is, and that's actually a really good introduction into, or I should maybe say segue, into why generics can help, and kind of answer your question too. Where did generics unlock new areas of functional programming awesomeness in Go, if you will? That's a technical term, awesomeness. So just for all the listeners out there. So I'll give it a crack to start off. The recap of functional programming. Really, you can go from a math perspective and say everything in FP is based on the function. Theoretical perspective, a function takes inputs and returns outputs. From a math perspective, right, you can chart a graph from a function, for example, just to map the inputs to the outputs. That's what it is. It's a mapping. In real life, of course, our functions don't just spit something back out. They also do some I/O, or maybe talk to a file, or use a timer, or send on a channel, or whatever else. And so that's really important, actually, to remember that all of this stuff that we're going to talk about in functional programming comes from the theoretical, but when we apply it, it looks like a design pattern. It's really not it's not like adopting a framework, or if you're in school, like doing an assignment. There's not just a right answer and a bunch of wrong answers, or a right answer and then everything else is just wrong. There's some gradients here, and we kind of saw that with there have been talks on FP before, including one that I did way back in 2017. There's been talks at GopherCon UK. There's another talk from GopherCon in 2020. And obviously, like you said, Johnny, there's been previous Go times. There's been blog posts. They all attack FP from a different perspective, right? And it was all possible to do some FP things before generics, right? So we were able to take some of the theory and apply it even before generics. Obviously now generics has unlocked more stuff, and now we can unlock more things. So, FP, the theory is things are based on the function. We can transform functions by putting two together, right? So if the output of one gets passed into the input of a second one, now you essentially have a transitive property where you can input to the first one and get an output from the second one, and it all looks like one function. Composition, right? You can curry functions, so you can think of it as partially applying a function, meaning if a function takes in 3 parameters, pass one of the parameters, and now you have a function that takes 2 parameters, and that first parameter that you already passed in is already baked into it, right? And then you can take those tools and go to what I kind of think of as the next higher level, right? So moving into the programming world, not just the math world, because all that stuff that I just mentioned is basically just the math world. In the programming world, you could have sequences of things, like a list or an array, or in Go, a slice. So what if you could apply a function on every item in the slice without having to write a for loop? That's called, in Go and a lot of other languages, it's called a map, right? You just apply the function on each element in the list, and then you get a new list out the other end that has the outputs of that function in the same indices as the respective inputs. Right. So now, starting to bend the mind a little bit, what if you had a function that took in an element of a list, but then output a list itself? All right, now you can do something called a flat map, where you take in an element, so you apply the function on each element. The output is a list, right? So now you're taking a bunch of lists and combining them together to make a much bigger list. Right? So whereas before you were just dealing with input one element, output another element, now you're inputting one element, outputting n elements for each element in the original list, and you end up with a much bigger list. Now you can go even further here, and you can start doing things like filtering. So if you have a function that takes in an element in the list and returns a Boolean, you can use that to decide, can I make a new list, and can I decide which elements from the original list are going to end up in the new list, right? You can also do things like zipping, which is using a function to determine the ordering of a final list given 2 or 3 or 4 or 5 or 6 or 10 initial lists, right? So you can determine how they're interspersed together. And I'm going to stop there, but there are a lot of other ways that we can sort of apply this very basic but powerful concept of a pure function, just takes in an input, returns an output, doesn't do I/O or anything else. So this concept of a pure function, and applying that into the programming world of maps and lists and other things, other data structures like trees and so forth. You know, this, forgive the overloading of the term list, but this list of things we can do, you know, it goes on. And I could spend another hour and a half talking about it. Of course, I'm not going to do that. But the reason that I went into all that is to kind of start to talk about what could we do before and what can we do now with generics, with the addition of generics. And really, thinking about generics, this is another branch of math. Right? We're talking about types here, statically defined types. And not only that, but now we're able to vary the type of the input of a function or the output of a function. We're able to vary that type based on a parameter. It's called type parameterization. Right? So if we can do that, now we can write one function in Go, but we can have an infinite number of actual implementations of it because the type can change. So if you've got a function that takes in a type parameter or a parameter of type t, where t is a type parameter, well, I can invent infinity types, right? So if I can invent infinity types, then that function can take in infinity different types of parameters, which means there are infinity different implementations of that function. And, you know, the Go compiler is going to figure out how to define actual implementations that take in those actual types. I don't have to worry about that anymore, which means I don't have to generate code or anything like that. But now that we have this power, and this is immense amount of power, now we can start to have things like, say, take the map example. We can start to have things like a single function called map that can operate on a list of any type. Instead of before, we had to have a function called map that only could operate on a list of one type. And we had to repeat the implementation of map over and over and over again for all our different lists. Now the compiler just does that for us like magic. Thank you, Go team. You know, you all gave us this opportunity to save tons of generated code, and that's amazing. Right? So that's kind of where we're at now. You know, the implications of this go beyond map. But fundamentally, now we're at a point where instead of using raw interfaces, or you know, the any type now, instead of doing reflection, now we can at compile time prove that certain functions will work for some definition of work, right? We can prove via the type system that certain types of functions will work, like map, for example. We don't have to wonder whether our reflection code or our type assertion on an empty interface does the right thing and figures out the right type of the list and then applies that to the function. Now we know that if our code compiles, that you've passed in the right function that takes in the right type for the type of elements in the list, and you will get back another list with the output type of that function in it.
So it's, if I'm hearing you correctly, it seems like now so we're no longer arguing about sort of the benefits of FP, right? So we you've done a pretty good recap of why you'd want to introduce FP, or at least know of its usefulness, right? In certain contexts. It's about now how easy is it to actually implement in an elegant way and go, and that's what generic gives us, right? Because like you said, there were FP libraries and talks and blog posts and everything. It was possible before. We just either had to write a lot of boilerplate ourselves, or use Go generate to produce a pile, basically a variance of a particular function to support the different types, as many types as we wanted to support, right? Or we had to do some voodoo with reflection to get to the some type information, right? So now it's about sort of the elegance, right, that we get to leverage, right, with type parameterization. Let's say that 3 times fast.
Yeah, seriously, right?
So okay, so if I'm understanding correctly, then some of the libraries pre-generics, is it fair to say that you were going to see a lot of, or at least for those who practice FP and are interested in practicing FP and doing FP and Go, which is something we'll touch on as a separate sort of a thread, right, in our conversation. So we can expect that a lot of those FP libraries are going to start adopting generics because it just makes the implementation that much easier.
Yeah, I think as someone who has written a library to do a bunch of FP things, I saw not only did it make the implementation easier in the form of less code and more guarantees at compile time about types, but also it extends those guarantees to the caller, so the user of the library too. So, like I said, I no longer have to take in an interface or any type and return an any type from, or a list of any types and return a list of any types from map. And since now I can return the type parameter t and then a new type parameter for the return type of the list, well, now those guarantees are extended to my user, the user of the library. And now they can also say, oh, well, my program compiles, therefore my types are right too. So this is like a domino effect of benefits that if a user is using someone's FP library, or even rolled their own, now they know that, well, my types are right. They don't have to remember, it's one less thing they have to keep in their head, right? That oh, well, the input should be a slice of ints and return should be a slice of strings, but all a compiler knew about in the past was it's just an empty interface. Or maybe a little better, a slice of empty interfaces or something like that. Mm-hmm. So it is simplicity, but it is benefit too. Sorry to interrupt.
No, you're right on. So when I was looking at sort of how Go provides this, or how Go talks about sort of this instantiation, right, of a generic function. So for those who haven't sort of gotten into generics yet in Go, pretty much when you create a generic function, what you're basically saying is that you're going to support a number of types, right, based on the typeset information you provide, and basically you're what happens behind the scenes when you compile your code is that Go is going to generate an instance, right, of your function for each of the types you say you support, right. So it's kind of like an actual code generation that we have that provides a type safety, the type checks, right? That the compiler is able to provide. Basically, we now the language itself is actually producing that for you behind the scenes, and you don't have to actually write your own generators, right? So effectively, you're doing the exact same thing you were doing before, except now it's basically baked in support into the language, right? So really, so the this is an efficiency gain, right? In terms of you, the programmer, being able to write these libraries, being able to support multiple types of given functions and things. This is an efficiency gain, really, not really a game changer for functional programming in Go per se, just a more efficient way of writing the functional the functions basically.
Yeah, yeah. So that is a really great point. Is that everything we can do now, technically, you could do before, because we had the empty interface, right? The empty interface is the set of all types, all possible types in this context. So you could have a function that take in an empty interface, and that is a function that can take in anything you can come up with, right? Same thing, it can return. If you have the empty interface return, then it can be the set of anything. So your task before was write the code to define a subset of all things that your function wants to deal with. Now, there is a massive efficiency gain, right? Because now you can constrain a type parameter and have the compiler compute for you whether a given type for a type parameter that has constraints on it is legal, right? Is allowed to pass, So do you want it to be integral, or do you want it to be comparable, or do you want it to be stringable, or anything else under the sun that we can come up with? You write, a line, less than a line of code, right? And maybe you write a new constraint somewhere, and then you apply it on your type parameter, and the compiler does what I consider a very advanced and very useful computation for you across your entire code base. And if you're writing a library, across everyone's entire code base that uses it. Which is pretty amazing.
Powerful.
Yeah.
That is amazing. That is amazing. So the Go team has been very vocal and deliberate about sort of advising pretty much everybody to not go gangbusters with generics on all the things, right? Not use it as a hammer, with everything being a nail, right? Just don't spread it everywhere. It's a very sort of cautious approach, right? Until some of the best practices start to emerge, until we can see the sort of the best use cases for generics in Go. Do you think that applies more, even more so for those who want to practice functional programming in Go, or do you think actually it makes our lives a little easier, let's just go full throttle?
Well, that is good advice for all software, I think. So yes, the answer to your question is yes, right? There is no telling right now whether map is enough, right? Or no one wants to use it. And if people do want to use map, there's no telling whether the parallel version of that is better or complementary to the regular serial version of map, for example. Right, so the parallel version for listeners would be, instead of applying the function on every element of the list one after the other, it's applying them in parallel with X number of Go routines, or at least concurrently with X number of Go routines, and then returning the result, right? There's no telling right now. You can say this is correct, you can say this is possible, you can guess this might be useful for this case, or this type of software, or that type of software, but there's no substitute for usage in the wild, in the community, if you will. There's just no substitute. So these things should be tried. Maybe we should go a little crazy, as they say, as the Go team has said, a little overboard to see what is possible, but we should not say that this is the result. This is the solution to all problems in FP. We should get these things out there, play around with them, experiment with them, see what works at a larger scale, and then say that is the solution to problems X, Y, and Z. There's just, this is why we all say we test in production, right? Because there's no substitute for real world use cases. Yeah. In that case, it's data, and in our case, it's programmers experimenting with things and seeing what actually works in real world code bases, but it's the same effect.
So piggyback off of that, the thread that we paused and now I want us to resume. You see what I did there?
I do. I love it.
The idea of basically the sort of the when to use, right, generics, right, and in our case here, when to use functional programming. I think that's a fair question to ask, whether or not, regardless of generics, right? So the one of the sort of the strong gripes that I found out there, right, that I've heard even in talking to some folks, is that, look, Go is imperative, right, through and through, right. We're kind of side, bending and kind of pushing it in a direction it wasn't meant to, right? Even though some of its features, some of its capabilities, like are well suited, right, for functional programming. Functions being first class citizens and et cetera, et cetera. A lot of the sort of the things you look for in functional programming you can do in Go, but just because you can doesn't mean you should, right? That old adage, right? So if like is functional programming still in the realm of sort of experimentation and just people who are curious and they can play around with it, but really like at work or whatever, right? They don't really use it, right? Like where are we in terms of, really, I guess it's an adoption question, right? Like are people interested, or increasingly more so interested in using FP? Now even with the bells and whistles that are enabled right through generics, is FP attractive enough for people who are traditionally doing this imperative style, especially in the world of Go?
Yeah.
Should they be looking, or really, should we try to bring FP into our production code?
Well, it's already here, right? Anyone who uses context is using a part of FP, right? Because context has a with cancel and with timeout, those return a function, right? This is how pervasive FP is. That is technically a higher order function, because it's a function returning with cancel is a function, and that's returning a function that you call to close to free the resources. There's an internal Go routine running, right, with a timer, and it frees that resource, right? That is FP, and I think like all technologies that are used by more than a trivial number of people in the world, a corner of this technology is used a lot, right? SQL is another good example here. You can do many things with SQL. You can turn PostgreSQL or PostgreSQL. Is that? I think that's how you say it, right?
Yeah, I'll allow it.
Okay. It's got the Johnny stamp of approval. So you can turn PostgreSQL into a time series database if you want to, for example, right? By using very advanced features of SQL. But not many people do that, because obviously it's a lot of times it's not the best tool for the job. But also, most people prefer, including myself, to stick with a smaller set of foundational features of the technology. And same thing with FP, right? There is a smaller set than even all the stuff that I said today. There's a smaller set of functionality that most people prefer to use. And my hypothesis for why that is because it makes more sense and it fits into more workloads, right? So if you need to capture some state of a function and expose one operation on that state to the caller, using a higher order function makes a lot of sense, right? It's a lot easier than doing a bunch of boilerplate and building a whole struct and storing the state in the struct and having a bunch of methods on it. And that, it just fits right into that use case, and it applies, that use case is applicable and exists on a ton of workloads, and so we use it, right? So FP, strictly speaking, is everywhere. Now I'm gonna modify your second question a little bit accordingly. You said, should we be trying to get FP into more workloads? Well, given that it's already in a lot of places, I'm gonna modify it and say, should we get more features of FP into more workloads? And Will you allow that? I'm going to pause and say,
yeah, let's do it.
Okay. So
Yeah,
Johnny
tell me
allowed.
more. Tell me more.
All right. So now we've got the seal on that. All right. And so the way that I think about it is try to model it as the imperative declarative difference, I guess. Right? There's a fundamental difference between imperative and declarative. You can see it with SQL versus Go, right? Because SQL, you say, dear database, this is the result that I want, and then the database has a ton of usually very clever implementation to figure out how to get whatever the way that it represents the data on disk into the result that you want, right? So you can filter, you can join, you can group, you can order, et cetera, et cetera, et cetera, right? Mm-hmm. Now, in the FP world, let's just take this map example I keep using, right? So with map, the intention is to take a function, apply it onto every element of the list, the slice, and then return a new slice with the results. Right? You might return the same slice with the new results. That's also sometimes legal as well. But let's just say, for the sake of logic, we're returning a new slice with new results. Well, we're iterating through a list, so that's a for loop. That's just what it is, right? We can write a for loop, and that's the imperative way. It's telling the machine to go through the list one by one, call this function every time, put the result into a new list. Or, and the other way is someone else did that for you, and you just call map. And that's the kind of declarative way. Because when you call map, you're effectively saying, like with SQL, you're saying this is the data that I want back. With map, you're saying I want a new list back with the results of the old list applied on the new on the function that I gave to map, right? And that's pretty much it, right? So when we think about this question of should we get more features of FP into language, into code bases that are mainly Go code bases, the way that I think about it is, would this code base or this part of a code base, would it benefit in some way from more declarativity? I think I may have made up that word, declarativity, but
it works.
I think people know what I mean, right? Would it benefit in some way? And there are a lot of possible ways that declarativity can help. It can reduce lines of code. It can add structure. It can add readability. It can also reduce readability if you're not careful. So that's a trade-off, right? It can fix bugs, like if you have an error in one of your for loops. And this happens a lot with parallel and concurrent code, and thus also code that deals with channel sends a lot too. I've seen that a lot as well. So it can reduce bugs because you're just getting someone else's code that did it the right way, right? So if you think about it in this way, and this is where I start with any code base. I always start, okay, well, is there code in here that we can reduce by using the declarative features of FP, whether it's maps or reduces or filters or zips and so on and so forth. And as a quick anecdote to close that thought out, I have seen filter as one of the most valuable tools to take and put into code bases, because tons and tons of code has for loops that reduce down into selectively taking things out of a list and putting them somewhere else, right? And that's filter, right?
Right. Awesome. Yeah, I can definitely see that. I think I think at least for me, it's a mindset shift, right? So like I don't have a reason not to use FP, right? Or not to bring some of the ideas, or not really, or that I should say, not to think FP first, right? In terms of how do I solve this problem, right? Like I'm so used to the way I'm used to doing it, right? So it's more of a sort of a I think maybe education, and maybe sort of seeing more people talk about it, present about it. And having shows like this where people knowledgeable like yourself come on and sort of advocate for it. I think it's more of a sort of a education issue more than the merits of it, because all these things you're talking about here, these are things that make my program safer. They make my programs easier to understand, right? And obviously, we, like as with everything in programming, we sprinkle things where they make sense.
Yeah.
And if your team at work is not using sort of FP style for things, and perhaps they want to or don't want to, so don't force it, kind of thing. But I think every once in a while, even using your example like filter, for example, that I see the use case for it. Now that you mention it, I see that everywhere. Like it could definitely be used in a lot more places, and maybe, who knows, maybe that sort of triggers somebody to say, hey, what's that? Like, I've never seen this particular approach, right? And then boom, that's a brown bag lunch right there. You can educate some coworkers around the sort of the merits of FP. So for me, I think it's an education thing more so than capabilities or features, which kind of leads me to my next question: is there anything missing in Go to nudge us even more towards sort of I don't want to say traditional FP, because I don't think we want to make Go an FP language per se, but is there missing features in Go that would allow us to even take even more advantage of FP concepts?
Well, it's so generics are young, and FP, using generics is even younger. Mm-hmm. So really the best I can do to answer that is hypothesize, based on very, very unscientific things like gut feel and things I've seen and anecdotal evidence, right? Mm-hmm. I think the biggest thing that could unlock just building these things a little easier would be type parameters on methods of a struct, right? Mm-hmm. Or a type, right? Mm-hmm. So you can't do that now. So you can't have, let's say you have a custom list type that's a list of type T. You can't have a method called map on that list that takes a type parameter U and then returns a new list of type U. You can still build map. I have done it, and I know others who have done it. I've seen it all over the place. You can still build it. It has the same effect, and it works the same. Mm-hmm. The reason that I'm hypothesizing that type parameters on methods would make things easier is because for many folks who are trained using Java or C++ or other what I'll call pure object-oriented languages, although whether they're pure or not is another podcast, but
pure
anyway.
in air quotes.
Yes.
Those not watching.
Air quotes. Yes, thank you for that call out. Definitely in air quotes. So folks who are trained with the classical OOP type of programming, the OOP design patterns and methodology, having a method on a struct feels a lot like a method on a class in Java. It's not strictly the same, but for folks who are used to thinking of methods, if you have a method, quote unquote, again, air quotes, if you have a method, air quotes, on your list struct in Go, well, it makes more sense to do it that way rather than to do it the more kind of pure, again, air quotes, pure FP way, which would be a totally separate function that takes in a certain type and returns a new type and so on. Again, that's not going to, for some of the things that I've talked about today, that's not going to limit or reduce or eliminate correctness at all. But there are some more advanced things that could be unlocked by having something called higher kinded types in Go. And maybe this is my unpopular opinion right now, right? It's just to say, higher kinded types make and I was just talking to my manager about this not 2 hours ago. Higher kinded types add a ton of complexity to a compiler and a type checker inside of the compiler. But they do offer basically something called a type constructor, which is a type that depends on another type, right? And if you can do that, I'll leave it as an exercise to the reader or listener or watcher, right? What kinds of things could you do with that? It'd take me a while to get into it, so I'm not going to go there now. But If you had that, right, now, assuming it was correct in the compiler, you can start to do some very advanced things. But the only thing that I'll say is whenever I've seen that feature in a language or not in a language and then introduced into the language, at that point it starts to become what you called sort of a functional language, right? Because getting to that level of sophistication in the type system often means that there are a bunch of people already there who have been demanding it, and those people are the majority, and those people write very heavily function-oriented code. So really, I'm going to just limit it to the type parameters on methods thing, because that thing is not very controversial. But higher kinded types or higher order types are a very interesting and cool thing that I really do wish was in Go, because it would enable some very slick FP things.
That sounds, that doesn't sound controversial to me. I could see that.
Okay.
Yeah.
Some might, maybe some people will think it.
Okay, so but before we transition into unpopular opinions,
Sure.
maybe I want one of those controversial ideas.
Okay.
All right,
Well,
let's get it going.
I will give, I'm not going to give one that talks about higher kinded types, because it's been a while, first of all, so I don't think I would do it justice, or maybe even get some parts incorrect, but also it would take me a while. But I want to mention one pattern from FP that I think is really great. And it's not that hard to do yourself in your code. I also don't think it's too hard to imagine how it would work in a code base. It's called the lens. So, it's maybe sounds like an intimidating thing to some people. It certainly did to me. The lens is essentially a tuple of two functions. One function is a getter for some data, and then the other function is the setter for some probably the same type of data. But you can have separate things too. You can have a getter for one piece of data and a setter for another piece of data in the same tuple. So usually it's the getter first in the tuple and then the setter second in the tuple. Now the first function takes no parameters and returns the result, the data. It might take one parameter if the data is multidimensional, like a map, and you want it to specify a key. And that's up to you. That's part of the design pattern. And then the setter potentially takes in the dimension of the data, again, like the key of the map. And then it also takes in the data that you want to set into that place, right? So it might be the value of a map if we're going to use the map, like the example of a map, right? And then it returns nothing. These things can alternatively return an error if this is like doing something over the network or something that might fail, but traditionally they're not, right? So if you could kind of imagine how these functions would be created, they would probably be closures. They would close over your data. They would take some parameter in the get, let's take the get case, for example. They would take the parameter for the thing to get, and then they would return the value of it. Same thing with the set. It would close over the data and then do its thing, right? It's a fancy term called a lens, but it's a fairly basic foundational thing, right? And that is a common theme in FP actually, right? So I called this the lens, and it is in Wikipedia and it's in the textbook and everything, but it just boils down to functions, like most things do. Boil down to one or more functions, maybe combined together in some creative way, or maybe one function applied across a data structure in some other way. Right. So I would challenge everyone listening to just give it some thought. Can that reduce code somewhere in your code base? If you have a bunch of getters, can you get rid of those getters and just replace them with a closure of the lens? Right. That's a very interesting one to me, because it is exceptionally simple. Well, I'll put it a different way. The return on investment is very high, right? It's very simple, but it tends to be applicable and useful in a lot of places in the code base.
Very cool. I'd love to see. I'd love to see that in action, like in practical use. It sounds. I mean, the way you explain it, it sounds great. I'm like, yeah, that sounds like something I'd be up for. Yeah, but perhaps we need sort of a blog post from you when you're done with school or something.
Yeah.
Yeah. So like, if you don't mind me asking, like, what did you go back to school for?
Well, I went back to school for computer science. I have been, I got an undergraduate computer science degree in 2008. So I'm not that old, but I feel older than I am, I guess. You can do the math, see and figure out how old I'm likely to be. And so then I've been in industry ever since, right? Just on industry things, right?
Right.
They all tend to be very practical, maybe, single goal oriented. And all of the learning that I've done has been very focused on a goal rather than broader. So I went back to get a master's to get that breadth again, because I've kind of missed that. Right now, I kept using the SQL and the database examples because right now I'm taking a course in databases, so that
there you go.
easy extension there. But yeah, I mean, one of the things, the thing that I'm planning to specialize in now is formal methods, because I love this stuff, like programming language theory and things like that. I really do enjoy it a lot. And the formal methods specialization happens to have quite a bit of language theory stuff in it. So look forward to that.
Nice. Yeah, it sounds like you're in your bread and butter kind of space right now. That's nice. Yeah, this is cool because yeah, and now that you mention it, interesting enough, like I think we tend to go to school to get a specialization, right? To narrow down on a very particular set of skills. So even though when we go in, we might not know that's what we're doing, but we're going to learn how to do X, right? And then we come out and we get a job to do X, right? It's very rarely do you go back just for the sake of breadth, right? Just to get basically to go find out what you don't know about, right? And then sort of see how you can sort of apply it to your already existing, right, set of knowledge that you require in industry. So that, yeah, I commend you for that. That's very cool. It's very cool.
Well, I'm very, very lucky and privileged to be able to do that at this point, right? Because I think probably all of us remember in undergrad, we probably just went so we could get to whatever our next step was. Most of us probably was a job, right? Maybe some of us was grad school, but most of us was a job. It certainly was me, right? I was laser focused on getting done so I could get paid.
Yeah.
But these days it's different, right? I have a job, and I'm able to continue working in this job while I do this part-time program. And so I fully acknowledge, and I try to remind myself daily that I'm very lucky to be able to do something like this just because I want to, rather than having to do something. Yeah.
Right. Pretty cool. Well, Aaron, unless you have another more unpopular opinion for me, although I don't think anything you said here is unpopular, man. I think maybe it's just the way you talk and put it, but I don't think any of it was unpopular.
Yeah.
Yeah.
Well, I do have an unpopular opinion.
Okay.
This one will be unpopular.
Okay, wait. Then I gotta pay the song if that's the case.
Okay. Let's do
All right,
it.
here it
Yeah,
goes.
let's do it.
I actually think you should probably leave.
Boom. Lay it on us.
All right. Well, I've been doing a bunch of Rust lately. Some very low level stuff, dealing with virtual machines. And I believe now that I've used Rust long enough, I believe the type system in Rust is more complete and leads to more concise and easier to write and read programs than Go.
Okay then.
Yeah, so the Go type system has some work to do.
Okay. Okay.
Yeah.
Well,
I don't
we're
mean
gonna
to
put
fan the
that-
flames of the Go Rust thing, but I'm
Oh,
sure I
too
just
late, buddy.
have. Yeah,
Too late,
I've
buddy.
just done it. Yeah. The flame war.
It's been 0 days now since the Flame Wars.
I know. But I talked a lot about type system things today, right? And it's not that Rust lets you do all those things. It certainly doesn't. But the type system in Rust has more features than the type system in Go. And it certainly allows for some programs that take forever to compile and are hard to read. So that's the pro and con thing here. But from my experiences so far, it lets you write more expressive code with fewer lines than the Go equivalent.
Okay. Well, we shall put that to the test.
Yeah.
The audience, and they will tell us whether they agree with you or disagree with you, and come find you in the night or something.
Yeah. You all know my Twitter, so you can send me hate mail. I still love Go. Don't get me wrong. I've been writing Go for something like 10 years or something, and there's no language I can build something more quickly in. And I'm just getting started with Rust, so this is my initial opinion, though.
Hey, you can love more than one language. That's cool.
Oh yeah.
As long as it's Go and Go, that's cool.
Love anything you want as long as it's Go. I love that. Yeah.
Awesome. So thank you so much, Aaron, for coming back on the show and talking about functional programming. Hopefully we hit a few nails on the head for folks that have been curious about functional programming and how it's done, how it's been done, and what generics enable for us moving forward. This was a fun discussion. Thanks again, Aaron, for coming on the show.
Thank you so much for having me, Johnny.
Cool. Watchers, this is a wrap. Thank you so much. Say bye to Aaron.